In this video, we discuss learning outcome number 1 from lesson 9.2, which is about the difference between dependent samples and independent samples. My hope is that by the end of this video, you'll be able to describe the difference between dependent samples and independent samples, and that you'll be able to determine whether two samples are independent or dependent. There's a reason why we study this, and that's because statistical analysis of comparisons between two population means are handled differently when the samples are independent as opposed to when the samples are dependent. It's important to know whether we've got two dependent samples or two independent samples so that we know which methods of statistical analysis are appropriate for our comparison between these two population means. So here are the definitions of these two terms. We say that two samples are independent if the sample values from one population are not related to or somehow naturally paired or matched with the sample values from the other population. We say that two samples are dependent, or that they consist of matched pairs, if the sample values are somehow matched, where the matching is based on some inherent relationship. So a couple of examples of dependent samples would be data from a husband and his wife. So if we have the data from one partner and the data from the other partner, and we're pairing those together, that would be a set of, or a pair of dependent samples. If you're looking at data from twins, you've got one twin and the other twin. Well, those would also be naturally matched with each other. If you're looking at before and after data, maybe you have a before quiz on some topic, and then you administer some treatment, and then you look at the after quiz on some topic. If you're looking at the score for a particular person before and after, those scores are matched because they go with a particular person. All of those would be dependent. Let's look at a few examples and practice classifying the pairs of samples as independent or dependent. So here are two samples. The first sample consists of the ages of actresses when they won the Best Actress Oscar. And the second sample consists of ages of actors when they won the Best Actor Oscar. Now, you might think that these are not naturally linked in any way, but they are naturally linked by the year that they won that Oscar. So you might have a Best Actress for that year and a Best Actor for that year. So there's a natural linking there. So that makes these two samples dependent samples. Now let's say you've got volumes of contents of 36 cans of regular Coca-Cola, and you've got volumes of contents of 36 cans of regular Pepsi. Well, there would not really be a natural matching between a particular can of Coca-Cola and a particular can of Pepsi on the other side, even though they happen to have 36 cans of each of them. So that would be a couple of independent samples. And then the last one deals with heights of the winner of the US presidential election and the heights of their main opponents. So usually in the US, we have a top two. We have a Republican and a Democrat, or before we had different political parties, right? But there were always two, or for a very, very long time, there were two political parties. Well, then there would be a natural matching between the winner and his main opponent, and we're looking at their heights. There would be no reason to compare, well, let's not even get into that. There is a natural matching between a winner and their main opponent. So that would be a pair of dependent samples. Okay, I think that covers it. I'll see you in the next video to discuss hypothesis tests involving two population means. And it will be dealing with one of these. The samples will either be independent or dependent. And I will talk to you about that in the next video.